Sorry ahead of time if you're watching this video. I forgot to start recording earlier. Whoops. You'll have to ask a friend if you missed the first part of the video. Alright. Back to the parents function of tangent. We are on range. So the range would be all the way to the bottom to all the way to the top. How low does it go? Negative infinity all the way up to positive infinity. But does it skip over something like cosecant skipped over stuff? It does not. So it negative infinity to positive infinity. Alright, so that was tangent. Now we're going to do cotangent, and the key points are different than tangent. So I'm going to start by telling you that we are for sure using x values that give us undefined y's at the start and the finish, just like tangent. And the middle one will be 0, just like tangent. But for this one, when we look at where cotangent is undefined and 0, it makes sense for us to use the top half of the unit circle. So we're going to go from 0 to pi, making pi over 2 the middle. And then we find the exact middle between those x's, and we get pi over 4, and then the other one will be 3 pi over 4. So when you think about at pi over 4, and you think about all students take calculus, is this going to be positive or negative? Positive. And then we think about 3 pi over 4 in the second quadrant. All students take calculus. That one is going to be negative. You can see that tangent and cotangent are pretty similar, and it's easy to confuse them. So that's why we have to know why these numbers are what they are, not really just memorizing. So we will graph every place we see an undefined, make that an asymptote. So it's 0, and at pi, and then continue the pattern. And graph our points. And it's not a reflection, but it looks like it's a reflection from the x-axis. It's not, but it looks like it's a reflection from the tangent to the cotangent. So what's the period? How far apart are the asymptotes? Pi, thanks. Good job. Domain and asymptotes are start with the first positive asymptote. What is the first positive asymptote on this graph? I should rephrase that. First non-negative. 0. And then we'll add on how far apart they are. So pi k, or k pi, where k is an integer. And then the range goes from negative infinity to positive infinity. You're ready to go on? Look at the next one and put in your key point. I'll be there in a moment. Could be. That would work also. I'm just trying to keep our answers somewhat. Right. Your answer of starting at pi and adding on k pi is totally fine. But I'm trying to keep us all having the same answer as much as possible to try to grade them. So I'm like, I mean, you can be creative, but there's no. Yeah. So if you put pi, like on a quiz or a test, I wouldn't worry about it. Okay, so before you just go way ahead of me and work ahead of me, I made a mistake, and then I copied it, of course, right? So I was trying to be very helpful to you, and there's nothing wrong with tangent. There's nothing wrong with this one. It's the second one there's something wrong with, so if you are working ahead of me, it's the second one. I was trying to be helpful and, like, put in your table with all the points, and then I, like, copy and paste it for each question, not thinking that cotangent is different. So, sorry, but cotangent does not have the points. This is cotangent right now. It does not have the points that I put on there for its key points. You're going to have to utilize whiteout if you have it, or this really crazy method called scribble out what I put there and write the real ones. So this is cotangent. Ooh, let me go back up. This is the one. This is the second one on your paper. This is cotangent, and cotangent goes from 0 to 2 pi. Not 2 pi. 0 to pi. Third time's charm. 0 to pi, pi over 2 is the middle, pi over 4 is in between. So I apologize ahead of time. I went too fast and I just copy and pasted, and then it wasn't what I was supposed to do. Okay, so go back to tangent. Tangent's fun. We have to put in our key points, which go from -2 pi over 2 to pi over 2, but if you can remember, we're starting and ending with the undefined, so that we can have that fun shape in the middle. At negative pi over 4, that's the fourth quadrant. Tangent positive or negative in the fourth quadrant. Negative. And then we look at our transformations. We've got a 2 in front, so multiply the y's by 2. And then we have a plus 3 on the y side, so we'll add 3 to each of those. What are we doing on the x side? Charlie, what are we doing on the x side? We are multiplying by 2. And then what are we doing on the x side? Plug in, do you know? Where are you getting pi over 4 from? Oh, did you guys factor? Did you factor? Did you factor? You remember to factor. Good job. I was waiting for somebody to tell me to do that, though. So to factor out the half. Am I still on the screen? And we get x minus pi over 4 plus 2, or 3. So then, yes, you're going to add pi over 2. Just kidding. Pi over 4. And I'm going to do that quick. Zoom out just a little bit. So my x column should be negative 3 pi over 4, negative pi over 4, pi over 4, 3 pi over 4, 5 pi over 4. They're all evenly spaced. When you're doing this, if you start graphing and they're not evenly spaced, you've done something wrong. So I like to put my asymptotes first, and then go in and put the points from there. Because again, they're all evenly spaced. So because we had a horizontal stretch, factor 2, that's going to affect our period. Normally it's pi, But since we're stretching it back after 2, we're going to take that pi and multiply it by 2. Period is now 2 pi. If you look at the graph, the asymptotes are apart 2 pi. Vertical shift is up 3. Phase shift, remember, is the left to right. So right, pi over 4. The domain and the asymptotes are similar to each other, so they're both going to be x equal, or one's going to be x naught, and that one will be x equals. The first non-negative is 5 pi over 4, and they are 2 pi apart, so I'm going to write 2 pi k, where k is an integer. So the domain will be the same thing, 5 pi over 4, except for it's not equal to. Plus 2 pi k, where k is an integer. Range is negative infinity, positive infinity. I do not want you to have to memorize all these things. I want you to be able to look at the graph and figure out the range. One less thing to memorize, you can just look at the graph and know, see it goes from down to up. All right, the last one is cotangent. So we fixed our ordered pairs. And what do we have? We have a 3 out. Oh, I got to put my y's in. Goes from undefined to undefined. 0 in the middle. And then we think about pi over 4, which is the first quadrant. So it's going to be positive or negative. Pi over 4 is positive. 3 pi over 4 is the second quadrant. Negative 1. We're going to multiply by 3, then we're going to subtract 1. And then on the x side, there's no stretch or shrink, so we're just going left pi. So at negative pi, and at 0 asymptotes, and then every evenly spaced asymptote from there. So I'm going to keep writing it, and then you can look up here if I'm going too fast for you. Or, hey, it'll be a video if you need to go back and watch it later, except for it's not the beginning. Period, nothing changed horizontally, no stretches or shrinks, so period is still pi. There was a vertical shift down 1, phase shift left pi. The asymptotes are going to start at 0 and add on k pi. The range will still be negative infinity, positive infinity. So I'm going to pass out the assignment, which is a worksheet. I copy and pasted the same table for every single one on the worksheet. So when you get the worksheet, go change cotangent immediately. Don't say, oh, I'll do it later. Like, just go change all the cotangents immediately, because I messed up. I apologize. Don't worry. When we do our review on, we're going to have a review on Thursday. I'll just leave the tables completely blank, so you can fill them all in.